Welcome everybody to the next event in the DSA seminar series. Today we're delighted to have Yulia Cherdantseva with us to talk about cybersecurity or an introduction to cybersecurity. Yulia is a lecturer in the School of Computer Science and Informatics at Cardiff University, but a lot of her teaching is associated with the National Software Academy. So without further ado, I'll hand over to you now, Yulia.
Yeah, thank you, Patrick. Hi, everyone. So very hot topic, cybersecurity. So I'm very excited about it. So I do typically get carried away talking about it. So I guess if you have any questions, just stop me and ask the question. That's perfectly fine. So I don't think I can see the chat immediately. So if any questions come on the chat, please do let me know. Or just unmute yourself and ask a question. So cybersecurity is all on the news. I guess everyone is aware nowadays about cybersecurity. So we rely so much on technology, on IT, on networks, and security is really a key issue within IT, within the tech sector. So if you think about online banking, online shopping, even digital education, remote teaching, it's all possible only because we have all that security behind it. So you won't send a message to your friends on Facebook, for example, if you're not sure that it's secure. So you only send it because you know that no one else but authorized people can see it. So security is really always at the background. It's really a foundation of what we can and cannot, or what we want to do online, for example. Just a quick kind of overview of the history. So it started in 1950s as computer security. Then the terminology changed, and for a bit it was information security. So from around 2000s we have this buzzing word cybersecurity. So that's what we are referring to the domain right now. So it's cybersecurity, but it incorporates computer security and information security within it as well. So if we start with computer security, and I think it's important to understand how did we get there? How did we get to where we are from where we were? So computer security was really focused on protecting those big machines. So big computers, only small number of those machines, and it was the actual machine which was valuable. So that's why it was computer security. It was protecting those computers. It was very often just physical protection, so it was a lock on the room, so you just simply cannot get physical access to the computer. So then it moved to access control, so it was about controlling access to those machines, to the information on the machines. And that's when the mathematical models for access control kind of frameworks came into play. So with information security, so when personal computers became more widespread, so we started to have computer networks and the internet. So then it moved to the network protection more or less. So it was around everything about firewalls and encrypted traffic. So it's about protecting networks. At the same time, information security is about protecting information more generally. So it was not just about protecting digital information, but it was a realization that companies rely heavily on information, on data, and it was protecting data more generally, not necessarily only within computer systems. And then we moved to cybersecurity. So when everything went online, so we have cloud computing, we have big data, we have smartphones everywhere, IoT devices nowadays. So that's kind of where cybersecurity came into play. So it's all about protecting our digital and online world. It is a very dynamic field, and I have this live threat map, and if I stop presenting, I could probably even show the threat map, which I have up and running here. So just, and with all the kind of buzzing that you can see there, that's just a small proportion of attacks, of cybersecurity attacks that happen every single second. So that's just one provider capturing traffic and attacks from kind of from their worldview. But in reality, it's much more than that, and it happens every single second. So with with all that buzzing around, I think it's important for everyone to understand where information security and cybersecurity sits and what's within the scope. So information security nowadays interpreted as a larger, kind of as a bigger discipline with broader scope, and cybersecurity just focuses on protecting digital information. If you look even at a kind of at a helicopter view where it sits within other disciplines, so it's risk management would be all-encompassing large discipline, and then we have business continuity, and information security strongly overlaps, kind of it sits within overall risk management, overlaps with business continuity, and of course information technology and all IT and ICT plays a significant role, and it's a significant part of the discipline. So it's overall it's very technical discipline, so it has strong foundations in computer science, of course, but there are elements which are less technical, and I'll talk about them in a minute. So I've mentioned, I already touched a little bit on this, why information security and cybersecurity are so important with all the online activities that we have nowadays and on which we rely so much. But really, it's companies realizing that information is an important asset. It's a very valuable asset. In addition to kind of growing dependence and overall dependence on ICT, if you think about companies such as Facebook and Google, and so what do they sell? It's the information, so that's their main resource. And of course, protecting that valuable resource becomes really, really important. I've mentioned this multidisciplinary nature of cybersecurity, and probably more than any other discipline, cybersecurity brings or benefits from that kind of interplay of different disciplines, and it really requires knowledge from different domains. So if you think about cryptography and the encrypted traffic that you have and all that confidentiality and integrity of information, it is guaranteed and ensured by cryptographic algorithms which rely on mathematics. So that's pure maths, and all the access control models and cryptography are based on maths. So maths is a strong part of cybersecurity. Computer science, I already mentioned that it's a very technical discipline, and in order to protect networks, you need to know the basics of networks. You need to know how they operate. In order to write secure software, to understand how to integrate security features and to protect your software, you need to know software development. You need to know how to write software to begin with, and then you can make it secure. So there are strong foundations, of course, in computer science and software engineering. Law and politics, that plays an important role because you know that a lot of new legislation is coming into cybersecurity because it's such a fast-moving domain, so rapidly evolving. Often legislation sort of lags behind, and policymakers, they try to catch up with the advances in ICT. And the good example is GDPR, General Data Protection Regulation, which was introduced in 2018. And of course, it scoped and it affected everyone working in cybersecurity, people in software engineering, because the way how they design software and how they develop systems and database systems would need to change to address the requirements of the new legislation. So there is a lot of effect that comes from the law as well, and from the legal side of things. Human factors and social engineering as an example. So that's a very significant element within cybersecurity, because ultimately it's up to the people not to click the wrong links and know how to behave online and how to think and care about the privacy and keep the information online secure. So psychology is very important. So, and that's a big factor as well. Business studies. So ultimately it would be businesses. I mean, most of the time, and students are very often tend to think about cybersecurity as hacking and red teaming and all this kind of cool and offensive security stuff. But in reality, and for businesses, cybersecurity is about protecting businesses. So it's not offensive security, but it's rather protection of the infrastructure, protection of information. And because it's one of the business activities, ultimately cybersecurity would need to align with business objectives. With business objectives, you need to think about risk management, risk assessment, and resource management, and really value that cybersecurity brings for business. So it's that kind of security economics and business perspective on cybersecurity as well, which is important and should be taken into account, because ultimately cybersecurity does not pay for itself. Unfortunately, it would have to be paid for by a business that buys that security services. So that's a lot of subjects, and they all have effect on cybersecurity. And really, it's only through understanding all of them and overall effect of them on cybersecurity we can see the full scope and understand the full scope of the domain. Cybersecurity is quite new, so I gave you a brief introduction to the history, but overall it's not that kind of, it does not exist like medicine for centuries and generations. It is quite new. And there is a good initiative which is called Cyborg, Cybersecurity Body of Knowledge, which tries to document cybersecurity as a domain, to identify which areas are included within cybersecurity, what they entail, what they mean, what topics should be taught, or what experts in that area should know about. So Cybersecurity Body of Knowledge, Cyborg, identifies 19 different areas in cybersecurity, and you can see them on the screen. So, and there are areas which are technical, obviously, and most of them are very technical, but there are areas which are less technical. And if you look on this side, so we can see that there is, let me just switch on my laser pointer. So we have risk management and governance. So that's of course, less technical. And if you think about the previous slide, that's where we connect with the business studies. So risk management and governance, how do we actually govern cybersecurity, how we manage it, and how we address it from the risk perspective. Human factors, that way we connect to the psychology. Privacy and online rights and law and regulations, that's from the legal perspective, how we approach cybersecurity and what effects it makes on our technology as well. And within it, we have all the technical areas focused on system security, on infrastructure security, and on software security as well. So focusing on web and mobile, for example, here, secure software life cycles, on how we actually develop secure systems, how we integrate security into agile project management, for example. And on this side, we can see more technical areas of security, such as malware analysis, adversarial behavior, forensics, and security operations and incident management. So those are the areas which are identified within cybersecurity at the moment. And clearly you can see the multidisciplinary nature of the knowledge areas within cybersecurity. So we have to think really about what is it that makes cybersecurity specific or interesting. I guess at this point it would be good to mention that there is a significant shortage of qualified cybersecurity professionals in the world. There is no shortage of reports showing that there is a skills gap there. Some reports say that it's up to just over 4 million positions. So there is a shortage of qualified professionals. It means that there are 4 million positions which are not filled, and companies are not able to fill those positions due to the lack of qualified professionals. It is not UK specific, so it's all over the world. So we see reports coming, national reports and international reports, which show that skills shortage. There was a recent DCMS report, again, which confirmed, and it was a massive kind of survey of industry representatives in the UK, and a significant percentage of them, I don't remember off the top of my head, I think it was like 68 and 54% for companies saying that they were not able to find qualified professionals to fill the gaps in their positions. And companies saying that inability to fill in those positions lead to additional risks and threats to the company. And that, and generally there is that lack of technical cybersecurity skills. So even if they employ people, they see that those people and graduates, they lack cybersecurity skills. So that's certainly, we can certainly say without doubt that there is a strong demand in qualified cybersecurity professionals. There is demand, high demand and interest from industry in cybersecurity skills and knowledge in general. So this slide really, with this kind of background information on the shortage of qualified professionals. So this slide is my answer to why we have that shortage of qualified professionals. So what are those characteristics of the domain that make it so special? So first of all, of course, it's the novelty, because it's a new field with all those initiatives trying to define the knowledge area. So the true answer is we haven't really quite understood what cybersecurity means, and there are still discussions trying to understand what it includes, what it doesn't include, and things like that. So another element is, of course, complexity. Complexity comes from the diversity, the breadth of scope, because there are so many different disciplines and other knowledge areas which contribute to cybersecurity. It's complex because it's an advanced level. You don't learn about cybersecurity sort of on its own. So it's always securing something. If it's system security, it's securing systems, maybe software systems or systems in a broader sense of the term. It may be securing networks. In order to secure something, you first of all need to have a foundational knowledge of the object that, of the thing that you're going to secure. So you have to have good foundational understanding of the key concepts of networks to begin with, to be able to secure networks. So it's that complexity which comes from the fact that security builds on top of something. It does not just exist on its own. And another thing is diversity, which I've mentioned, and multidisciplinary nature. And the final factor is constant evolution. So it changes every day. We have new threats emerging every day. And of course, we try to keep our education and programs on cybersecurity up to date. But every single year, we have to update our module descriptions. We have to keep up to date with the new threats which emerge almost on a daily basis. So new technologies, if for risk assessment, we thought stride approach a couple of years ago, now we have comments from industry, no, that stride is dead, we don't have to teach it, we have to teach MITRE framework instead. So we have to really move fast in this area, because new technologies come into play, new threats and new methods of addressing it. So those are the specifics of cybersecurity as the domain. So I've been talking for 13 minutes now. Are there any questions? Anyone wants to ask anything, or do you want me to carry on talking, or we want to have a discussion at this stage?
If you want to ask a question, you can unmute yourself, or if not, you can just put the question in the chat and I can read it out. So I've got one question, Yulia. So you said there's a lot of jobs in this sector. So is it possible to maybe partition those jobs into different categories of jobs? So if our students are graduating soon, what different types of jobs exist in the sector that they could potentially move into?
Yeah, that's a good question. So I have a different slide on that. Let me just switch between the presentations and. So that's a very good question, and that's something which is an ongoing process. So just yesterday, Cyber UK conference started. This is the largest UK event in cybersecurity, run by the National Cybersecurity Centre. And they have just launched UK Cybersecurity Council, which will be responsible for understanding what are the roles and professions and career paths within cybersecurity. So there is another existing organization, which is Chartered Institute of Information Security. So they've received the chartered status just, I think, a couple of years ago. So that was an important movement. So it meant that information security is now recognized by the government as a profession, where you need to have a qualification in order to enter the profession. So kind of thinking about what it was in the past, because cybersecurity was quite new. No one knew what it's going to be like. Very often, and there are examples, and I've met people like that. They're now running their own kind of pen testing companies and security companies. How they entered the domain. So they were students or kind of they were interested in cybersecurity. They learned to hack machines. They hacked into a company. They went to that company just demonstrating that vulnerability, and then they were hired by that company to work on them on protecting the infrastructure. If you think about David Mitnick, so he's very famous, but again, how did he enter the domain? So he just was hacking into systems. So he served his time in jail for that, but now he's a consultant, and that's the way into the domain. So it's not true anymore. Nowadays, you have to be a qualified professional. You have to have a qualification to enter the domain. So it's very unlikely that someone will get into a good role without having a qualification. But within the domain itself, there are still lots of clarity. There is a lack of clarity on how you can really kind of progress in your career, what roles are available, and everyone uses the terminology kind of whatever they can come up with. So we can see a little bit of that, of course, as well, due to just the immaturity of the domain as a whole. So I'm trying to bring up a slide with a list of roles that we have. Let me share my screen again. Okay. So that's from. Yeah, sorry, that's me. Yeah, I guess I'll do it this way. Sorry, it was my voice recording on that slide. So that is a list of job titles which are available. So we are starting with Chief Information Security Officers, IT Directors, IT Security Directors. In many companies, security as a thing is not differentiated from IT. So security would be just a component of IT. So a head of IT or IT director would be responsible, or IT manager would be responsible for security as well. So in that sense, all the IT roles, they include security as a component within their responsibilities as well. So more specifically, there are roles such as security architect, security consultant and advisor, obviously, security analyst, compliance officer, security administrators, all IT staff. To a certain degree, they would have security responsibilities, and of course, software and application developers and testers. They would need to know about security, and they will be responsible for security as well. So, in terms of the education that security professionals normally have, so most of the people in the profession, they would have a bachelor's degree, and nearly 30% would have a master's degree. So it's kind of well-qualified profession. So you have to have a degree in order to be able to do the job. Although there is a small kind of percentage of people with just a high school diploma or associate degree, for example. So.
Yeah. So another question I have is, a lot of our students, when they graduate, they don't like working for an existing company. They like to maybe start their own company, a startup company. Is there much scope for startup companies, or how difficult is it to do a startup company in this space?
I guess as difficult as in all the other domains. So just recently we had a talk from Alacrity Foundation in our MSc module. So I'm not an expert on startups, so I don't want to give you too much information because I may be wrong there. But just based on that presentation, and that presentation is available for everyone who is interested to watch in our module Cybersecurity for All, and where Alacrity Foundation and people from Cardiff Uni who support startups, they talk extensively about startups and what support is available. Clearly, I can say that there are a lot of people who enter this domain, IT in general and cybersecurity specifically. I guess the failure rate would be more or less the same as for all the other industries, which is about 50%. So on most, or even more than that, so most of the startups, they fail according to the statistics. But certainly it's an interesting field, and there is a lot of support. So there is support from Cardiff Uni in terms of creating and developing ideas if students want to set their own business. There is support from Alacrity Foundation. There is a government support scheme which is called Cyborg ASAP, and they provide support and funding for research ideas which generate from academia in cybersecurity industry, and they will help to develop those ideas and turn them into real businesses. So, yeah, did I answer your question?
Yeah, I think so. It sounds like there is opportunity, but it's not necessarily any easier or any more difficult than any other IT sector.
I wouldn't say it's any easier than I wouldn't say it's any easier than any other technical kind of any other area in the technical sector. Yeah, Fernando, you have your hand up. Did you have a question?
Yeah, so one of the areas that I'm always really interested in, you brought it up, is sort of the social engineering aspect of it. And I've always been a fan of Kevin Mitnick and the Takedown movie.
Sorry, he's Kevin. I called him David, didn't I? So he's Kevin Mitnick.
Did you? I didn't hear that. Anyway,
said Mitnick, and then I thought, no, he's probably not David. Yeah, he's Kevin.
Yeah, but anyway, Mitnick, I've always been a fan of him, right? And sort of like the social engineering, you wrote the book, The Ghost in the Wires, and that was like, how he just called people up and said, oh, just give me your password because I've forgotten to come into work today and all that kind of thing. And what I was sort of like wondering is there's no, whenever you think of hacking, like you said, you think of, somebody sitting in the basement and trying to break into stuff, and the hard code, sending Trojans and doing all sorts of sort of hacky things. But one of the biggest things I think that people can steal is, when you get your message saying, oh, that you've had a payment from HSBC, just click on this link so that you can, and all these things are a way of digital social engineering. And I was wondering if somebody wants to learn about this and train in this kind of thing, because social engineering is more of a psychological warfare in a sense with somebody else. So you have to be the confidence to go in and go, I just forgot my wallet or whatever, and I've actually done this once or twice in a few years ago. I'll tell you in person, not here, how I did that to get through security in a very high security place.
Yeah, I remember you told, I think, one of those.
Yeah, and I have no formal training. This was just for fun. Looking back, I shouldn't have done it because, but the question was, if somebody wants training in that kind of social engineering or to protect against that, which usually for me, to train against that, you have to know how to do it in the first place. How can one go about doing sort of like training in social engineering? Is that something that you get taught, or there's a course on it? Is it a psychology course that you take? Because it's a lot more about talking to people, understanding the leverage that you have. How do you go about learning more about that? Is there like a training course that you can do, or how do you know more about it?
Yeah, that's a very good question. So in terms of degree programs, it would be covered to a certain degree within computer science programs, within cybersecurity programs. So we certainly do cover it within our MSc program. I don't think that I ever saw MSc programs which would include like a cybersecurity psychology as a specific module, but it's certainly addressed within the modules as a session or two on human factors. So they may be addressed at the different levels, but typically an MSc program would cover that at a certain level. I think School of Psychology, they have sessions. They certainly have sessions on cybersecurity. They're probably not kind of so well developed, and we certainly don't have like the entire module on that, but as sessions they would be available. Certainly there is quite a wide range of training in the in the professional sector, which would be focused on social engineering. So those trainings, and if you look at the NCSC website, National Cybersecurity Center, they offer a list of all the trainings, and there will be a lot on social engineering, obviously. I think that's, so I was at a very relevant session yesterday when we were discussing with colleagues from across the UK about how cybersecurity should be taught. And I think this multidisciplinary nature of things, it is taught within computer science degree programs, but we are just starting to move to the state of things where those programs are kind of jointly taught across the schools. So it's like things relevant to cyber psychology will be taught by School of Psychology. So it's not, we are just starting to move there, but it's not like it's not happening 100% at the moment. So at the same time, having said of all that, there is a lot of research and a lot of research funding in terms of cybersecurity. If you look at our School of Psychology, they have millions and millions of pounds of funding for them looking at cybersecurity, and there are great results coming from kind of looking at awareness and behavior change and all the psychological elements, and now how you react to kind of thinking about autonomous vehicles and how users of autonomous vehicles react to it from kind of all the from the psychological perspective. So in terms of research, a lot is happening, so it's certainly being addressed. How it moves to education, I think we have a long way to go before it would be like properly addressed in the programs.
Cool. If you're ever doing anything with social engineering, sort of as a research thing specifically, let me know. I'm really interested in that stuff, even just to watch.
Okay, yeah. So I don't do anything specifically. I've been teaching it to. In our outreach programs, so you've been involved, Fernando, as well in outreach. So when we do it for school age children, for example, I do social engineering because that's something they can really get interested in. There's something they can understand and relate to. So we do it there. So we teach it in MSc, but it's not like a primary focus on our program. And I don't say, I'm not aware of any research specifically that our kind of psychology school, they don't necessarily do research in social engineering, so they have slightly different focus. Okay, are there any other questions?
Hello, thank you for your sharing. I'm wondering if I attack your computer or I attack your website, how do you know I'm attacking you? I mean, how do you analyze, how do you trace me? What date I left in your computer or what date I left in your website so that you can trace me? And how confident that you will think I am an attacker?
So that's a good question, not an easy one. So there are lots of ways, and we're just going down to specific technologies. So there are lots of intrusion detection systems. Many of them nowadays rely on machine learning, so machine learning algorithms and data analytics. So there are already algorithms which can look at the traffic, for example, and they can identify which traffic is malicious and which is not. So we can start from something as simple as a firewall. So how would firewall work? So it will look at the traffic, at the signatures, at the headers, and try to analyze based on the previous information whether it's a malicious request or not. So with kind of what sort of traces, so in terms of when an incident happens, I think it was the second part of your question, how you can kind of trace it back. So there is an area in cybersecurity called forensics, network forensics, in this specific instance, or digital forensics. When looking at the kind of post-event evidence, we can trace back to the incident, and there are specific technologies which can help you do that. So it's I think going into too many details, it's just going into our modules more specifically. But forensics would deal with kind of post-event analysis of the evidence and analysis of the networks and like images of the machines as well. So whatever happened, they can take a snapshot of a machine and conduct forensic analysis in it as well.
Thank you. Because I'm always afraid of people attacking my website. based on this reason, even I'm working in a company as a leader, I'm every day worry about the security. Yeah, and yes. I think that the only way to to do the security things is to build a large infrastructure to know what events I should record and how to analyze it.
Yeah, with web applications, again, there is a wide range of things that you can do. So it's not that difficult to implement a secure web application. Of course, it depends on the specifics and what kind of information you have on host. But to begin with, a good user input validation is the first wall of defense. If you just filter all the user input, that's a very good protection from most type of injection attacks, and injection attacks are the most popular. So secondly, having encrypted traffic, if you set up a HTTPS connection so that all traffic to your website is secure and the traffic between your web application and your database is secured by TLS SSL protocols, for example. So that's most of the threads are going to go with those two features being implemented, good user input validation and encrypted traffic. And then on top of that, you can apply additional measures, but just with those two, you will sort out significant percentage of the threats.
Thank you.
So are most attacks these days taking place at the human level, so as opposed to at the hardware level? So kind of the attacks profile has moved up the stack, let's say, or is it kind of still at all levels?
No, I would say it's at all levels. It's just, we have to look at the problem holistically. I think you will have this kind of one-sided view. The danger is to say, okay, so we sorted all the technologies and now we are perfectly secure. That's incorrect. You cannot never be secure if you just look at the technologies, because next hour, one of your executives clicks a wrong link and all your technical protection is going to be wasted. At the same time, you cannot go without having that technical protection, because it will collapse even faster without it. So what I like about kind of, as I said, it's holistic protection. It's looking at all the aspects of the technical aspects, at the aspects of networks and IT infrastructure and information itself, and looking at the human aspects as well altogether. So what I quite like, and previously everyone was saying that people are the weakest link in protecting the infrastructure, right? So we all know that. But I think the way we move now, and the correct statement would be to say that people could be the strongest link in your protection as long as you educate them properly. And that's where we have to move. So we have to educate people, to educate our users, to make sure that they are the strongest link in the protection, and that technology and people work together to protecting the infrastructure. So that would be the best approach, not blaming everything on people and saying that they are the weakest link, but educating them and training them so that they become the strongest link in this chain.
Are there any final questions for you?
Yeah. One more. So we have time for one more.
Yeah, I wanted to find out how secure applications are that are deployed in a cloud environment. At least we get the impression that within the cloud space, there's security for the environment, the platform itself, but then at application level, there could be vulnerabilities in there. So what's your take on how to secure those stuff?
Okay, so that's a good question. So again, my answer should come with a caveat that I'm not an expert in cloud security, so I'm not personally securing infrastructure in the cloud. So my take on this is that in general, applications and whatever it is deployed in the cloud, whether it's services or platforms or IT infrastructure in general, it will be more secure than if you do it just on your own, because there you would be relying on all the security that comes with your contract. So there will be a lot that your cloud provider will do for you, kind of in the background. So at the same time, it depends on how you buy that. If it's, for example, platform or IT infrastructure, you buy and you set up your own infrastructure, it will only be as secure as you set it to be. It doesn't matter that it is in the cloud. So there still may be vulnerabilities introduced by the way how you personally set up your IT infrastructure in the cloud. But if you just buy it kind of as a pre-configured service from the cloud provider, I'd say on average it would be more secure, because cloud provider would have put all the effort into securing that pre-configured service.
Thank you.
Right, so I think that's all of the questions. Anything else we have? Any other questions?
I don't think so. Okay, so we can bring the session to an end. So thanks again, Yulia, for a very interesting talk and an interesting discussion as well.